Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the compression bone plate for its topology optimization. We are going to first do the static structural analysis and then we will go for optimizing the design of the compression bone plate. So we will first go to static structural, then I will go to engineering data. I am adding the material stainless steel 316 grade. If you have it in the version that you are using, you can directly select the material and use it. Since I do not have the material in my version, hence I am creating the material. The first property I am going to add is the density. The value is 8070 kg per meter cube. Next is isotropic elasticity. The Young's modulus is 2.5 gigapascal, so it is 2.5 E9, and the value of Poisson's ratio for the material is 0.275. You can also add the value of compressive and tensile yield strength if you want to find the safety factor. Now that is not the concern of this analysis, hence I am not adding those two properties. You can check the analysis of compression bone plate static structural analysis, wherein you will find the entire analysis done. Now I'll go to project and update the project. Next I'll go to geometry and I'll insert the compression bone plate. I am using the compression bone plate with 6 holes in it. You can use any other compression plate and analyze it. Next I'll go to model and double click on it. I'll first go to geometry and allocate the material. Next I'll go to mesh and I'll change the sizing to fine and update. Next I'll go to static structural and insert fix support. I'll fix these holes. Click on apply. Then I'll insert force on the plate. I'll change vector to component, and along the y-axis I'll insert a force of 1/10 of the weight of the patient that we are going to talk about. Say the patient is of 60 kgs. So when you convert this weight into Newton form, it will be 60 into 10 approximately. So that is 600 Newton. 1/10 of it is 60 Newton. So I am taking 60 Newton as the value on this compression plate. Next I'll go to solution and insert deformation total. I also want to see the strain and the stress generated over the body. Let's also check the result of deformation along the y-axis. So now I'll go to solution and solve. First we will see the total deformation over the compression bone plate. The highest value is 0.000136 mm. You can animate and see the results, and the minimum value is 0 over the plate. Next is the equivalent elastic strain over the body. The maximum value is 2.09 into 10 raised to minus 5. You can see where the maximum elastic strain is generated. Next I'll go to equivalent stress. The maximum stress generated is 4.26 megapascal. So this is very small a value which is acceptable for the compression bone plate. And the last is the directional deformation. This is along the y-axis. So you can see the maximum value is 0.0001 3378 over the body. So once the static structure analysis is done, I will go to the module of topology optimization. I'll drag and drop it over the solution. Next, I'll go to setup and double click on it. So you can see the screen appears, wherein at the initial stage you can see the static structure analysis module, and then it is followed by the topology optimization module. So now you can just go through the options available for topology optimization. The first is analysis settings, wherein you can see that the maximum number of iterations it will run for is 500. You can increase or decrease this value, but 500 is actually a very large number, so you don't have to increase the value, and you neither have to decrease it, because in case the number of iterations are just 50 or 100, so that's okay, you are just given a higher value. Minimum normalized density is also given over here. Convergence accuracy is 0.1%. You can increase this value such that you get better results, but I am leaving it to whatever it is. The solver type is program controlled. I'm not going to change that as well. Next is optimization region. You can see that the region where you have applied the boundary condition, that is where you have applied the force and fixed. Excluding that area, the rest of it will go for the optimization of design. You can see here, this is the design region, and this is the area where you are going to have no change in dimensions. Next is the objective. Now the response type is compliance. I want to minimize the value of either mass or volume that I'm going to choose in the next option. So suppose if I see here response constraint, it is telling me the mass can be reduced to 50%, and here it is showing percentage to retain, as in how much you want to retain, and the rest obviously is subtracted off. So we are going to go for mass constraint, and the mass to retain I'm going to change this to 30%. Next I'll go to solution and solve. So once this is done, you can go to topology density and you can see how the reduction in mass has taken place. This is the region which is left in grey color. So it is written here, keep 0.6 to 1. Marginal is 0.4 to 6, which is over here, and remove is 0 to 0.4. So they have reduced that much amount of material, and this is what is left for me, and I can design and optimize the board plate. So you can read here, it is written to perform design validation after topology optimization. Invoke the transfer to design validation system. Drop down option from the result cell of the topology optimization cell in the project schematic. So basically project schematic is the screen, and it is talking about this results option, wherein I have to now right click, transfer design validation system. So whatever result you have obtained here will be transferred to another static structural module. Next I'll go to result again and I'll update. Then I'll go to the next geometry here which is created. I'll right click and update this again. So once this is done, now I'll go to geometry and double click on it. So once you come to the screen, first you will uncheck this system 1 such that the additional part which has to be removed can be just removed off, and I'll get only that portion of the design which I have to now optimize. Once this is done, I'll click on edit sketch and I'll use the select option and I'll select the entire thing. Then I'll click on copy and paste. So I can see that this portion has been copy pasted. Now I'll go to this system 1 and I'll uncheck this as well. So once this is done, I will now go to rectangle and I'll draw a rectangle here of 87 mm, and this distance I'll give as 15. Next, I'll have to just optimize this design. Now, what these green lines indicate is an area which has to be maintained. You cannot remove this area because this was the zone where you must have got more stress or strain. So, if I cannot remove this area, I can just redefine the rest of it. So, I'll click over here on bend and I'll select this. I'm just giving a shape which I find preferable. You can make this into any design of your choice. So I'm just bending these two and also bending these two lines. Next I'm selecting this option, create rounded corner, and I select here and bring it to this end. So I just made some shape here roughly, and also over here I'm going to create a shape. Now once this is done, I will create some random shapes around it. So I'll just remove certain areas such that this design becomes good enough. So once the circles have been made, now I'm going to draw another shape randomly over here. So I'm going to draw a hexagon of 4 mm side. So once this is created, I cannot change this area. So I'll just trim this off. So once the shape has been created, next I'll go to pull option. This shape gets selected. I'll choose the direction. I'll give 3.5 as the dimension. So this is the compression bone plate which I have created now. So this is done. Next I'll come to this project schematic screen and I'll go to model and I'll double click on it. It is asking if I want to read the upstream data. I'll click on yes. So this is the screen where I'm going to arrive. Next I'll go to geometry and I'll go to the solid one. I'll right click here and suppress all other bodies that have come along with it. Then I'll go to the assignment and change the material to the one that we have created. Then I'll go to mesh and I'll change the sizing to fine and update. Then I'll go to fix support. This is something which is going to appear from the first analysis that we have done. You don't have to basically add anything. You just have to select the geometries and just run the solution once again. So it is asking for the ends that are fixed. So I'll go to this end here. I'll click on apply. Then I'll go to force. I'll select this face. I'll select the face where I had applied the fixed support and the value is already shown as 60 Newton. Then I'll go to solution and solve once again. So now you can see here, this is the total deformation over the plates that we have redesigned. The value of total deformation is 0.00035 for that new geometry that we have created. The equivalent elastic strain is now 0.0001125, which is the maximum value here. and you can have the equivalent stress generated as 20.73. Now this value has increased as compared to the initial result, but then also you can get, but then also the result is in control. So you can use this. Apart from that, what you can do is you can fix up these ends also. So once you fix up these ends, you will get even better results. So that's how you go about with the topology optimization. With this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.